we're going to look at a couple of application problems for quadratics at this point. And so we're going to start with a problem having to do with the New River Gorge Bridge. The New River Gorge Bridge is the world's largest steel single arch bridge. And it runs across the New River, so it's called the New River Gorge Bridge. And it is a span with an arch that runs across it. And so we want to ask ourselves some questions about this bridge. We want to know, first of all, how high the bridge is, and we want to know how long the bridge is. Now, let's define what we mean by that. First of all, we want to know the total height of the bridge above the river. But I'm going to tell you that from this bottom span to the river is 516 feet. So really what we need to find here is the height from the bottom of the arch to this bottom line where we come straight across at the bridge over the river. And then we want the length of the span that's above the arch. So we're looking for this length right here. Now, in order to find that, I need to tell you something else. I need to tell you that you can model the arch of this bridge with the quadratic y equals negative 0.0000498 x squared plus 0.847x. So when we are solving this, we're going to need to use that equation. Now, kind of a long number, but we're still going to do exactly the same kind of thing. I need to find how tall this is, and I need to find how long this is, how wide this is. So how do you think we're probably going to look at finding that? Well, we're going to find the value of this vertex right here. So the first thing we're going to say is that the vertex is equal to, x is equal to negative b over 2a. Well, look closely at this equation. I've got an a value. This is my a value. And I've got a b value. Notice what I'm missing. I'm missing a c value on that one. So we can assume it to be 0. It's kind of irrelevant to our problem. So this is a, this is b. So the vertex, x is equal to negative b over 2a. So it's equal to negative 0.847 divided by 2 times negative 0.000498. Now, I don't expect you to do that by hand. Put that in your calculator. Put it in your calculator and you get approximately 850. So that's my x value of my vertex. Well, what's the y value of my vertex? Y is equal to, and all I have to do is plug this 850 back into my equation. So negative 0.000498 times 850 squared plus 0.847 times 850. And again, I don't expect you to just figure that out in your head. You can type that in your calculator, and you get y is equal to approximately 360. So when we do that, we find that our vertex is 850 and 360. So what does that give us? That's the value of this point right here. Well, the y value would be the distance from here to here. That's my y value. So if I want the height of the whole bridge here, what do I have to add into this? It's not just 360, because 360 just takes me down to here. And I want to go all the way down to the river. So I'm going to add that 516. So the height of my bridge to the bottom of the span is 876. Please don't just write 876. 876 what? Well, what unit was I using in my measurements? I was using feet. So it's 876 feet. Now, I need the length. I want to go from here to here. The length of the bridge above the arch. And so from here to here was 850 feet. So if I know that distance, remember my quadratic, my parabola is going to be symmetrical. So if it's 850 feet from here to here, it is also 850 feet from here to here. So if I add those two together, I will find the length of my bridge. My bridge is 1,700 feet long. Make sure you put your unit on the end of the problem. One very typical type of problem we see with quadratics, where we're looking for a maximum value. We're looking for a height. We're looking for this length. And a lot of times when we find our vertex, that gives us this, but our length ends up being twice that. So don't forget, we need to figure out where we're going. Are we going just as far over as we are to get to the top, or do we need to go all the way over to the other side, which means that number is going to double. Let's try another one that's kind of typical of the kind of problems that you will see with quadratics. This particular one has to do with figuring rectangles. So let's clear this off here and make this go away and start a new problem here. Here's my problem. I have a rectangle, and this rectangle has a perimeter of 140 yards. Now, I don't know how long each side is yet, but I know that my entire rectangle, which is length in one direction and width in the other direction, has a perimeter of 140 yards. I know that if I want to, let's say that this is land and I want to buy this, that it costs me $10 per square yard. Well, and I have a total cost of $12,000. I want to know what are the dimensions of my rectangle. You know, I probably got a little different bit of information than I normally would. Let's move this over here so it fits there. $12,000 is my total cost on for my land here. So let's go back and figure out, what can I figure out? First of all, can I write an equation that will get rid of one of these variables? Can I write an equation with perimeter and length and width and then use that to solve? Well, let's try it. 140 is the perimeter, and we know that perimeter would be length, width, so 2L plus 2W. And I don't want to work with but one variable, so let's solve for L here. So 140 minus 2W is equal to 2L. I just move the 2W over, and then divide everything by 2. So 70 minus W is equal to L. Okay, so we got that. We'll come back to that in a minute. We're going to use that again in a minute. Well, if my cost is $12,000 and it's $10 per square yard, then if I want to figure out my area, can I write an equation that involves cost and area? And I can. Cost is equal to whatever my area is times that $10 per square yard. So let's solve for area. Cost divided by 10 is equal to area. Well, I know cost. So 12,000 divided by 10 is equal to 1,200. So I now know the area of that rectangle. The area of my rectangle is 1,200 square yards. So if I want to find the dimensions, area of a rectangle, how do we find the area of a rectangle? You've known that for a long time. Length times width. But we want one variable here, so we've already solved for this L. This L is equal to 70 minus W. So 70 minus W times W. Well, if I distribute that W, look what I have. 70W minus W squared. Ooh, that looks kind of familiar. Kind of like a quadratic. Well, I know area is 1,200. So if 1,200 is equal to that 70W minus W squared, how can we go about solving that? Well, we've learned lots of methods, and we're going to learn some more methods, but for right now, let's just set this up to factor this. Let's do w squared minus 70w plus 1200 equals 0. And look what I've done. All I've done is move this 70w and this negative w squared to the other side. Change sides, change signs. Can I factor it? Sure. What multiplies to give me 1200 adds to give me negative 70? Well, w minus 40 and w minus 30. Zero product property, either this factor is equal to 0 or this factor is equal to 0. So either w is equal to 40 or w is equal to 30, which means that the dimensions of my rectangle, either w is equal to 40 and the length is equal to 70 minus 40, so 30, or w is 30 and length is 40. It doesn't really matter which one's which. So my dimensions are 40 yards by 30 yards. And we have solved a fairly typical quadratics word problem by factoring our quadratic.